Hi, I am Christina. Okay, so first we want to start by figuring out the domain of this function. So I'm looking for the possible x values where my function will not work. Now I know that I can never have 0 in my denominator, so I'm going to start by setting my denominator to 0 and figuring out what value of x would give me a 0 in the denominator. So here I will subtract 27 from both sides, divide both sides by a -1, and then I can go ahead and take the cubic root of both sides, giving me x equals 3. What that tells me is that my domain will be all real numbers except when x equals 3. Next, we need to identify whether or not we have a continuous function. Now, because this function has a domain of all real numbers except x cannot equal 3, that means it's not continuous. I have a spot in my function that does not work. So it is not continuous. Next, we're asked to check for horizontal asymptotes and vertical asymptotes. Horizontal asymptotes, we have a structure that we follow. We're going to compare the exponents of the numerator and the denominator and look at that relationship using this comparison here. I notice I have a 2 on the top and a 3 on the bottom. 2 is less than 3, and my rule is that if the top exponent is less than the bottom exponent, my horizontal asymptote is the x-axis. That's the line y equals 0 is where I will expect to find a horizontal asymptote. I'm also asked to check for vertical asymptotes. Vertical asymptotes, similar to the format we used to explore the domain, I am looking for what values of the denominator can I not have. So I know I cannot have x equals 3. That's where I would expect to have an asymptote. However, I do need to go ahead and just check to make sure that is an asymptote as opposed to a whole. And I'm going to do this by factoring. I can go ahead and factor my numerator. I will wind up with x plus 4, x minus 1. Now normally I would go back and just FOIL that to make sure I got it right, but I assure you that I did. Now we're going to go ahead and factor the denominator as well. Now to do this, I can pull out a -1 and then simply use my difference of cubes formula, which I have written here for us. So that becomes this. Great, and what I'm looking for is just to see if this x minus 3 cancels out with anything on the top. It does not, which means I do not have a whole, and x equals 3 will be my vertical asymptote. So vertical asymptote at x equals 3. Great. Now we need to verify that. So I'm going to use my graphing utility, and I will plug in the original function. Now it's really important here that I separate my numerator and my denominator by parentheses. That's a habit that I want to get into because with most problems, if that is not done, it will result in an error. I go ahead, I plug it in, I press graph, I look at my graph and I verify what we had determined, which is that we have an asymptote at x equals 3, a vertical asymptote at x equals 3, a horizontal asymptote along the x-axis on the line y equals 0, and that our function is definitely not continuous. Now we can also verify this numerically, which means with a table. On my graphing utility, I can find the table function. On my utility, I press second graph, which gives me the table function, and I'll notice it pulls up a table for me where I can see, as I scroll down, that every number seems to work except when I have x equals to 3 And my graphing utility says, in all caps, error, verifying that our domain is in fact all real numbers except for x equals 3. And that is how we do this problem.